Hi, this is Mrs. Hines, and today we're going to take a look at number lines in ways that can help you measure time and distance and weight and mass and capacity. So the first thing we're going to do is take a look at number lines that are more complex than the ones you took a look at when you were in kindergarten. This page is linked to my live binder if you want to practice on your own, or you can pick up the web address here. Basically, this is a number line I'm using to measure something. When I take a look, I know this is covering 1, 2, 3 whole units and part of another one. It's somewhere between 3 and 4. I'd list the whole number here, 3 and something more. This other part, I know that each of these intervals needs to be equal, and there are 1, 2, 3, 4, 5 of them. So I know this is broken into 5 parts. This length is covering 3 of those 5 parts. And so the length of this line is 3 3/5. I can check it here. And go on to a new example. Feel free to help yourself on the live binder site, but right now we're going to take a look at how you use these. One of the ways you'll use these is you will use number lines is to measure temperature, and I know you'll do a lot of that in science class. This temperature is somewhere between 100 and 120 degrees Fahrenheit. There are 5 intervals here covering 20 degrees. They must each stand for 4. 104, 108, 112, 116, 120. On the Fahrenheit side, this is 112 degrees. Take a look at the Celsius side. Now these same 5 intervals run between 40 and 50, so they're only spanning 10 degrees. They must each be 2. So 40, 42, 44, 46, 48, 50. On the Celsius scale, this is 44 degrees. When you're measuring distance, small distance or large distances, this is another place where we'll use number lines. This line, to measure its length, I could take a look at millimeters, which are these very small lines here. From here to here are 10 millimeters, 20, 30, 40, 50, 51, 52 millimeters. It's more likely, however, that I would measure with these units. These are centimeters. This is a little over 5 centimeters, 5 2/10 centimeters. When measuring inches, in inches, this line, I know it's somewhere between 1 inch and 2 inch. It covers this much space. There are, beyond the 1 inch, there are 1, 2, 3, 4 of those, and it covers 1. So it covers a whole inch and a fourth more, 1 1/4 inches. The longer line covers 2 inches completely, and then it covers 1, 2, 3, 4, 5 of these 8 spaces. This line is 2 5/8 inches long. This is a triple balance scale. You'll use this often in science. This tells you weight in 100 grams, mass in 100 grams. This is in 10 gram increments, and this is in 1 gram from here to here, 1/10 of a gram in between. So this happens to weigh 100 plus 90 plus 5.5 grams, 195.5 grams. Number lines are also how we tell time. When I look at this clock, I know that I'm past 11 o'clock, so 11 hours have passed, and then 12 minutes more. 11 hours, 12 minutes. I'd like you to take a look at how much liquid is in this beaker. I know this is 700, this is 800, this is 750. It's somewhere between 750 and 800, about halfway in between, 775 milliliters. Taking a look at this beaker, again, I have to use my imagination to visualize the difference here. This is 20, this is 30, 25, maybe about 21 milliliters. When I take a look at which contains more, this looks like it contains more, but this is 40 milliliters, and so is this. They both contain 40 milliliters. They're equal in size. When I look at these cylinders, it seems obvious that this would have more because the height of the liquid is further, but take a look at this measure. This is a little over 15, about 15 2/10. This is about 37 milliliters, and I know 37 milliliters is a lot more. The one on the right actually has more fluid. Tomorrow in class, we'll be measuring some things around the room. Be ready.